Get ready to have your mind blown as we embark on a cosmic journey through the 10 largest entities that defy comprehension in the universe. From mind-boggling superclusters stretching across billions of light years to colossal black holes with masses that defy imagination, these cosmic giants will leave you in awe of the immense scale and grandeur of our universe. Brace yourself for a mind-expanding adventure through the biggest, grandest, and most awe-inspiring entities that the universe has to offer. With technology rapidly advancing, astronomers are finding more and more objects in the universe. The title of largest thing in the universe is changing almost yearly. Some of these cosmic objects are so large that they baffle our best scientists, and some of them shouldn't even exist at all. Here are 10 of these biggest objects. 1. The supervoid. Recently, astronomers have discovered the largest void in the known universe. It lies in the southern constellation of Eridanus. Spanning 1.8 billion light-years, it's baffling scientists who never imagined such a thing could exist. Despite the name void, a void in space is not empty. It is an area of space that is underdense, in this case having 30% fewer galaxies in the surrounding area. Voids make up 50% of the universe, a number that's only expected to grow as gravity pulls all surrounding matter toward itself. Two things stand out about this void: its immense size and its relation to the mysterious WNAP cold spot. 2. The newfound blob. In 2006, a mysterious blob was named the largest structure in the universe, although it quickly lost its title to newer discoveries. This blob is a giant mass of gas, dust, and galaxies that is 200 million light-years wide and looks like a cluster of green jellyfish. It was found by Japanese astronomers who had been studying a region of the universe known to have large concentrations of gas. To do this, they placed a special filter on their telescope, which coincidentally allowed them to pick up the presence of the blob. Each of its 3 arms has galaxies packed 4 times denser than the universe's average. The galaxies and the gas bubbles contained within the blob are called Lyman alpha blobs. These are believed to have formed a mere 2 billion years after the Big Bang, just a blink of an eye in the cosmic timeline. Scientists think they formed when massive stars from the universe's earliest days went supernova and blew out their surrounding gases. Because this structure is so large, astronomers believe it is one of the very first to have formed. They theorize that in the distant future, even more galaxies will emerge from the gases contained in the blob. 3. The Shapley supercluster. For years, astronomers have known that the Milky Way galaxy was being pulled through the universe at a speed of 2.2 million kilometers per hour toward the constellation Centaurus. Astronomers theorized that this was happening due to a great attractor, an object with a gravitational pull strong enough to draw our galaxy toward it. They couldn't know for certain, though, because it lay behind the zone of avoidance, ZOA, the part of the universe obscured by the Milky Way. But while conventional astronomy couldn't penetrate the ZOA, X-ray astronomy eventually became advanced enough to peer through the haze and locate the great attractor, which was revealed to be a large cluster of galaxies. However, there remained a problem. The attractor they found couldn't create a pull as strong as what astronomers were detecting. It only accounted for 44% of the observed pull. Focusing their telescopes out even further, they soon found that our galaxy's cosmic tow truck was itself being pulled toward something even larger, the Shapley supercluster. 4. The Great Wall. The Great Wall, or CFA2 Great Wall, once held the distinction of being the largest known object in the universe. It was discovered by American astrophysicists Margaret Joan Geller and John Peter Hucra during a redshift survey for the Harvard-Smithsonian Center for Astrophysics, hence the name CFA. The structure is estimated to be 500 million light-years in length and 16 million in depth, and it's shaped somewhat like the Great Wall of China. The exact measurements of the Great Wall, however, remain a mystery. It can be much larger, stretching out to a possible 750 million light-years. The problem with determining its true size lies in its location. Like the Shapley supercluster, the Great Wall is partially obscured by the zone of avoidance. The ZOA makes 20% of the observable universe extremely difficult to detect because dust and dense gas in the Milky Way, as well as the high concentration of stars, heavily obscure optical wavelengths. 5. The Laniakea supercluster. Galaxies tend to group in clusters. Regions where clusters are more densely packed than the universal average are called superclusters. Previously, astronomers mapped these objects by their physical locations in the universe. But a recent study has found a new way of mapping the local universe, one that is shedding light on its unknown corners. The new study maps the local universe and its galaxy clusters based on gravitational pull instead of position. This new method charts the positions of galaxies to infer the gravitational landscape of the universe. It's considered superior to the old system because it allows astronomers to map the uncharted regions of the universe as well as what we can observe. Since it relies on detecting a galaxy's influence instead of the galaxy itself, it can detect objects even if we can't see them. 6. The Sloan Great Wall. The Sloan Great Wall was first discovered in 2003 by the Sloan Digital Sky Survey, a survey mapping hundreds of millions of galaxies to reveal the large-scale structure of the universe. The Sloan Great Wall is an enormous galactic filament that contains several superclusters that weave through the universe like the tentacles of an enormous octopus. At 1.4 billion light-years across, it once held the title of the largest structure in the universe. The Sloan Great Wall itself has not been studied as much as the superclusters within it, several of which have proven quite interesting in their own right. One has a rich core of galaxies trailing away from it like tendrils. Another has a high rate of interaction between galaxies within it, including some that are still actively merging. 7. The Huge LQG. A quasar is an extremely energetic region at the center of a galaxy. Powered by supermassive black holes, quasars have an energy output 1,000 times greater than anything found in the entire Milky Way. The current third-largest structure in the universe is the Huge LQG, a cluster of 73 quasars spreading out over 4 billion light-years. This large quasar group, LQG, and others like it have been proposed as the precursors for many of the larger-scale structures in the universe, such as Sloan's Great Wall. The Huge LQG was discovered after analyzing data from the same survey that located Sloan's Great Wall. Researchers posited its existence after mapping the area with a Friends of Friends algorithm that mapped the density of quasars within a certain amount of space. The method, though, is not without its skeptics, and the existence of this particular structure is a matter of debate. 8. The Giant GRB Ring. At a whopping 5 billion light-years across, the second-largest structure in the universe is the Giant GRB Ring. Aside from its enormous size, what's odd about the structure is its peculiar shape. Astronomers studying gamma-ray bursts, large bursts of energy created when a massive star reaches the end of its life, picked up a series of 9 bursts, all a similar distance from Earth, that formed a ring in the sky more than 70 times the diameter of the full moon. Given that gamma-ray bursts, GRBs, are a very rare phenomenon, the chance for such a shape to form randomly is 1 in 20,000, making researchers speculate that they had stumbled upon the then-largest structure in the universe. 9. The Hercules Corona Borealis Great Wall. The current largest structure in the universe was also discovered by astronomers scanning for gamma-ray bursts. This structure, named the Hercules Corona Borealis Wall, is 10 billion light-years across, making it twice the size of the Giant GRB Ring. Because the bigger stars that emit GRBs are typically formed in areas with more material, astronomers treat each burst as a pin sticking to something bigger. When scientists found a region of space in the direction of the constellations Hercules and Corona Borealis that had a large number of GRBs, they determined that the structure was probably a dense concentration of galaxy clusters and other matter. 10. The Cosmic Web. Scientists believe that the distribution of the universe is not random. It's been theorized that galaxies are organized in an enormous universal structure with thread-like filaments connecting dense regions. These are interspersed between less dense voids. They call it the cosmic web. The web is believed to have formed very early in the history of the universe. It began with small fluctuations in its earliest formation, which later helped shape all existence. The filaments, in particular, are believed to have played a large role in the universe's evolution, which is accelerated within them. Galaxies inside the filaments have a much higher rate of creating stars. They are also more likely to experience gravitational interaction with other galaxies. It's a process that is likely continuing even now. Inside the filaments, galaxies are sort of pre-processed and funneled toward galaxy clusters, where they then go to die.